In today's video, we'll be studying on the introduction to automatic control. So we have these three gadgets here. We have the electric iron, the washing machine, and the rice cooker. So then we must know that all these gadgets have their various functions. They have specific functions. This is for ironing clothes, washing clothes, for cooking. Please note that with automatic control is concerned with means by which systems are made to behave in a desired way. So the iron is the use of the iron is different from that of the washing machine, same for the rice cooker. And let's know that with these we have the objectives for using these gadgets, and we have the control elements in these gadgets. So to simplify automatic control, disregarding the complexity of these systems consist of one, we have the input or the objective. This maps towards the control element. And this control element will give us the required output or our results. So this is the basic schematic for any control system. We have the input, we have the control element, which gives us our results. The objective of using the iron is to make sure our clothes are ironed well or are straightened up well. And these have control elements in them, resistors, insulators, and a whole lot. And all these will give us our output, what we are looking out for, our results. The reason why I'm using this iron. So then we have classifications of these control systems. We have classifications of these control systems. So the classifications, we have what we call the first one, which is the open loop control system. The open loop control system. And the open loop is the system in which the control input to the system is not affected any way by the output. It's not affected any way by the output. So let's take the washing machine for instance. When you place in the dirty clothes and socks and all, you see that when you set the timer to the maximum time, let's say 15 minutes, after 15 minutes, the machine stops. When it does that, it doesn't mean that dirty clothes inside are cleaned or washed well. So the input is not affected by the output in any way. So there are no feedbacks, there are no sensors in it that will tell you that the clothes inside or the socks inside are not washed well. So in here, there are no feedbacks. So let's look at that of the closed loop. And this is the schematic diagram for the open loop system. It has the input, the process unit, and the output. There are no sensors inside. So let's look at the closed loop. So which of these three do you think is a closed loop? Let's first define what a closed loop control system is. So this is a system in which the input is affected by the output. And here we have a desired output. So you can see that with these three, what do you think is the closed loop control system? The iron. Because you can set the iron, you can regulate it at the regulator side. You have the cutting, you have the maximum, we have numbers on it to regulate the heating of the iron, where we have the thermostat, which controls the heating of this system. So here there is a feedback. When you regulate it at 1, the temperature there is lower to that of 2. So this is the schematic diagram for any closed loop control system. We have the desired value, the summing point, the controller or the processing unit, the output, and we have sensors in here who will give the feedback. So this is the feedback path and this is the forward path. So the forward path is the same as that of the open loops path. That's from the input, the process, and to the output. But here we have feedback. So next up, we'll be dealing with the block diagrams in automatic control.